Look at the Great Pyramid of Giza. It is a massive mountain of engineered stone, and its exactness has invited speculation since its completion. For millennia, people have projected their own beliefs onto these monuments. We search them for hidden codes, lost civilizations, or mystical alignments. But to truly understand them, we have to strip away the mythology. We need to look at them strictly as physical objects, structures built by draftsmen and surveyors, defined entirely by measurable geometry. When we do that, we find something far more interesting than alien theories. There is a precise, overarching mathematical blueprint that connects seemingly separate monuments across the desert. Take the bent pyramid at Dashur. Its distinct shape comes from a sudden shift in its slope. If we analyze its dimensions, a specific ratio emerges between the width of its lower base and the upper section where the angle changes. This is an intentional design choice. The neighboring Red Pyramid and the Meidum Pyramid share this exact same geometric relationship. Multiply the Red Pyramid's base by 2.618, and it matches the Meidum Pyramid's perimeter. Apply that same multiplier to Meidum's base, and it equals twice the Bent Pyramid's base. Multiply the Bent Pyramid's base by 2.618 to find the exact perimeter at its bend. These are not independent architectural experiments. The exact mathematical repetition shows these pyramids were designed as modular components of a single, linked geometric chain. This exactness presents a massive historical problem. The ancient Egyptians did not use decimal mathematics. They also had no documented concept of phi, the irrational number we commonly call the golden ratio, which is mathematically embedded in that 2.618 multiplier. This chart extracts measurements from the bent pyramid, an upper base of 236 cubits, resting on a lower base of 360. Reversing that ratio to 360 to 550 identifies a constant. The master scaling operator is approximately 1.309, geometrically equivalent to phi squared divided by 2. Executing an irrational multiplier with this level of flawlessness across massive stone structures directly contradicts the established limits of Old Kingdom arithmetic. This graphic proves the 1.309 factor is a universal scaling operator applied across entirely different architectural modules. It dictates everything from half bases to total perimeters. This proportional progression in royal cubits begins with Khaba at 160. Multiplying by 1.309 scales continuously to 210, 275, 360, 472, and a 618 extension node, before finally reaching the massive 809-cubit perimeter of the Djedefre pyramid. This is a continuous, repeating chain. It proves generations of Old Kingdom pharaohs were building from a shared, highly deliberate architectural code. To understand how they achieved this without complex equations, we have to look at the physical workspace of an ancient draftsman. This diagram shows the first step in their field geometry, establishing a baseline by plotting a perfect square. Next, they bisect the base of that square. This locates the exact mathematical center without requiring any written calculations. Using that midpoint as a fixed anchor, they extend a radius outward to the far corner of the square. Then they simply drop that radius down to the baseline. This simple action creates a new physical extension of the original starting length. That physical extension perfectly produces the 1.309 scaling factor observed in the stone monuments. The math emerges naturally from the shape. This visual proves how a single, repeatable geometric arc maps directly onto the dimensions of the Khaba, Red, Meidum, Bent, and Djedefre pyramids. The builders were not calculating irrational numbers. They were generating them physically as a byproduct of a simple, elegant spatial construction. This sophisticated architectural sequence required no written algebra. It relied entirely on the physical mechanics of taut lines mapped across flat planes. This specific rope and stake surveying method is historically verified. Archaeologists like Mark Leaner have documented these exact rope stretching techniques as the primary tool of Egyptian draftsmen. When you look back at the staggering mass of these monuments, the real achievement is the immense discipline required to hold that geometric line true over hundreds of feet of shifting sand. This disciplined application of field geometry allowed the Old Kingdom to achieve mathematical perfection across the desert, defining the dimensions of a civilization with nothing more than a rope and a stake.